We started with 18650.
Ah.
Currently, it's a battery. You see in the bottom, we have fins,
Hmm.
right? And then fins are also not straight;
Right.
they're curved.
I know Tarun's stand on battery swapping, and you probably have the same.
Right.
But all of this would go for a toss if they were swappable.
Yes.
Like, why Ather chose to engineer its own port versus the Type Type 6, which is common.
Yeah. So
A Cybertruck has this feature where if you enable water wading, it pressurizes the battery just in case. So Athers, many people are asking what could they charge their friends Ather with their Ather? What are the challenges with it?
Most people do not understand that nuance. That while the feature might be same, the auto hold, the way it is implemented in a car and the way it is implemented on the perturbation, which is every control loop, there is a correction, right? Like now it goes down to how strong your PID loop is. You burn the energy in the motor winding itself. So what that ensures is that
since you are on the motors,
right?
What kind of motors? One was popular question, and secondly, why did you have that? I like that sound of Ather, but why is it second wheel and then it transfers instead of for your dashboard?
Right.
I don't know what it is now, but earlier it was Snapdragon 212 and 2 GB RAM. Is it still the same? And is this the processor powering the rest of the electronics, or do you have like two different computers for your?
Actually,
to give you a quick intro of this whole interview, the person you saw on screen was Swapnil Jain, who is the co-founder and CTO of Ather Energy. He, along with Tarun Mehta, the other co-founder, founded Ather Energy. As you know, Ather sells electric two-wheelers as well as other energy solutions. They talk a lot about engineering and their philosophy with two-wheelers, etc. So I always wanted to do a technical interview with someone from Ather. I got this opportunity to do it with Swapnil, who is also the CTO. So you will see that this interview is very technical, might be even more technical than the Skyroot Rocket Factory tour which I did in the previous video. So if you have any doubts, try to look it up, or worst case you can put it in the comment section. Either me or someone with knowledge might reply. Also, you'll see the interview ended slightly abruptly. It's because we were short on time, so almost half of my questions I couldn't ask. And yes, there are timestamps in the description, and as usual, I don't add mid-roll ads or the in-between ads to my videos, so you can enjoy this entire interview without any interruptions. Enjoy. So one popular question was what cell chemistry you're using and why you're using. Has it changed over the time?
Right. So we've used actually the chemistry, even if you call it as an NMC or NCA, with the proportion of nickel, manganese, cobalt keeps changing. So we started with somewhere around 732 sort of a chemistry, and then it has evolved. Now we're around 811 sort of an NMC chemistry. But we have multiple chemistry, not just NMC. We have occasionally tried NCA chemistry as well.
Okay. Yeah. So what kind of cells? 18650 or are they the bigger, more denser?
So 2170 is what we use. We started with 18650. Currently we use 2170. We migrated in 2020 around. We migrated to 2170 form factor.
Okay. Well, that brings us to a good point of how does the battery look? As in, people think it's simple to simply buy the cells and then staple them together and make a battery.
Right.
But I guess it must be more complicated of managing the thermals of this whole system. How do you?
Yeah, actually battery engineering is very complex. Like you can make it sound very simple because it's series parallel connection and done with it.
Right.
But that's fine for a prototype. But then when you want to actually put something into production, it has to work reliably for 10 years and it has to work in different climate conditions and occasionally also handle abuse. Then the things start becoming very very difficult, right? Because cells are very they actually need a lot of care in a sense. You need to protect them from vibrations. You have to protect them from thermals, especially thermals, more than anything. You have to ensure that they don't go below a certain temperature. They don't go below a certain voltage. They don't go above a certain voltage, and they don't go above a certain temperature. So all of this management around the battery is very critical. That's where the entire battery management system and the algorithms which go into the battery management system become very critical. And it's not about operating at one particular temperature. You can design a BMS to work at a one particular temperature, it will work fine. But now the same BMS has to work for 10 years which means that there will be a drift, some sort of a drift. So you have to compensate for all those sort of a drift which will happen. You have to compensate for the temperature variation within a day, within a time. As the components age, they will again start having some sort of a drift in their characteristics. You have to compensate for that as well. So it's not about one designing for a particular instance, but designing for the 10 years of life and compensating for various noise factors which start coming in and component to component variation, right? Like one board is fine, but when you have to make millions of boards, then again how each component will have some sort of a variation. So there is a part-to-part variation. So how do you compensate for those part-to-part variations? How do you calibrate your BMS to ensure that part-to-part variation? That becomes very critical. When it comes to the battery pack in itself, except the BMS and the algorithms, battery pack is also very, very complex. You have to ensure that, like for example, like if you have used a Ather vehicle, you will know that Ather vehicle is the only one which never derates in its performance at any kind of temperature. That's primarily because of the amount of effort we have put into the thermal engineering of it. And what it has multiple aspects. The first important aspect is having an aluminum casing, which ensures as much heat is generated, it's getting dissipated as quickly as possible. Then comes the placement of the battery itself. Having the battery in the floorboard ensures that you get a continuous wind draft while you are riding. And then third is something is a patented technology where we have a phase change material inside the battery. The phase change material ensures that even in the harshest of the conditions, your battery never overheats. And all of this put together, along with and which means like you have to do a thermal engineering, even have to study the aerodynamics around the battery. You have to do all your latent heat calculations to ensure that the vehicle runs seamlessly across all temperature conditions.
Right. So there must be gaps between batteries, right?
Yeah.
So how does the heat sink into the frame of the battery?
Yeah. So essentially, it's the entire joining methodology. There's a layer of adhesive of sorts which ensures that every cell is thermally connected to the battery, which ensures that irrespective of the gap between the cells and variations on the surface of the battery casing, all your heat is transferred directly to the casing.
Okay, and you were talking about aerodynamics of the floor,
right?
So does it mean having a rougher surface? Does it lead to, like, you're talking about also the surface area of the floor? Is that also important?
Yes. So we have if you pick up the battery, you see in the bottom we have fins, right? And then fins are also not straight; they're curved fins. So it's essential to break the boundary wall and ensures that while the vehicle passes through, you get the maximum amount of cooling from the battery.
Right. So, does there exist a liquid cooled Ather somewhere in your lab?
We in the early days we tried. What we realized is that the cost it adds does not it is not adding as much of value to the customer, right? Because even in liquid cooling, unless you have like a refrigeration, right? Liquid cooling in itself is not enough, because liquid cooling will still bring it down to ambient temperature.
Right.
It will be faster than air cooled, but it will still only bring it down to the ambient temperature. And if your ambient temperature is very high, that's still not going to help much. So what we rather achieved is that without using an active cooling system or rather a liquid cooling system, how do you still bring in similar amount of thermal dissipation, and hence even the PCM technology which goes in to absorb transient shocks which can come into the battery, thermal shocks which can come into the battery.
Right.
It absorbs that and ensures that it's a constant temperature. So it and hence even at the harshest of the temperature, the battery still continues to not overheat.
Right, I think that was one popular question. Did you have to engineer specifically for India all of this?
Oh yes, I mean, like the entire vehicle we have to engineer for India, right? Like, because neither electronics nor battery, none of them like high temperature.
Right.
And well, whatever it is, India's climatic condition, you have to design for high temperature, there's no running away from that. But at the same time, you also cannot afford to put a lot of high-tech cooling stuff into it.
Right.
It will add to the cost, which obviously becomes again prohibitive. So how do you engineer a vehicle which works for the harshest of the climatic conditions, especially on the higher side of the temperature, and still is not adding a lot of cost? And the thermal engineering has been one of the toughest engineering when it comes to the forestry design.
Right. I know Tarun's stand on battery swapping, and you probably have the same.
Right.
But all of this would go for a toss if they were swappable.
Yes.
Like,
A lot of the engineering which we are able to do and provide the kind of consistent experience would actually not be possible with a swappable battery. Starting from the position of the battery itself, right? Like as soon as I say that I need a swappable battery, you can't put it in the floorboard.
Right.
There goes a lot of your thermal management.
Center of gravity also.
Center of gravity goes up. Your vehicle doesn't feel as good. Then you can't have that. Like today we have an aluminum casing. You would want, and that makes the battery slightly heavy. Right. But that's important from the thermal management perspective. If you're making a swappable battery, you will want to put a plastic casing.
Right.
Because you want to make it lighter. But if you put a plastic casing, again thermal management goes for a toss. So a lot of the decisions on thermal management actually don't work out as well for a swappable battery.
Right.
And that's why, and especially when you do a swappable battery, you would end up splitting the battery into two, because one single battery will be very heavy. Nobody will be able to lift one single battery. As soon as you split battery into two, again cost gets added because you need two different BMS to run them, and you have to balance between the two battery packs.
Correct.
So a lot of cost gets added when you make a split battery, and that's why. And again, there is a lot of operational hassle as well. So engineering wise, it is expensive, and operations wise as well, it's a lot of cost to run a battery which is swappable. The entire operations setup, you have to have extra batteries which you have to keep in. You have to maintain the temperature of those batteries as well.
Correct.
To have an attendant to swap the batteries or something of that sort.
Right.
There's a lot of complexity which comes in with battery swap. It's good for fleet, but not good for a B2C or rather D2C application.
And what about when that whole thing happened, when you tweeted that we'll limit the charging to 80%,
Right.
But you won't disconnect. You'll completely turn it off and disconnect.
Yes.
Won't keep it hanging because sparking issues and can come. Like what people were requesting was just loosen the port, but let it continue charging. So if anyone wants to, could those same issues happen on a swappable battery pack as well? Like arcing issues with connectors.
So I mean, you have a design for it. Obviously, parking can happen if you don't design for it. And again, that adds to the cost as well, because you're constantly disconnecting and connecting. Your contacts become more expensive, right?
Right.
Now imagine, so usually contacts, the number of mating cycles of a contact is an important cost driver. And now as soon as you say, okay, I need to swap once a day or twice a day, then you are talking about probably about a 150 to 200 swaps, 150 to 200 contacts a year.
Right.
Which means that about 2,000 mating cycles in a life cycle of the the product. That becomes very expensive when you talk about like 2,000 and that kind of a current, right? Very high current, very high voltage, and 2,000 contacts, mating cycle.
Right. So this patent, I think this is the current one. Also looking at the shell of Ather.
Yes.
So the battery, all that is the aluminum frame of the battery is also part of the structure of the whole scooter.
Yeah, so that is what we had designed as well.
Right.
On the day one, we knew that the battery is going to be aluminum, and hence we want to ensure that the structural rigidity of the battery adds to the rigidity of the vehicle, because 450 is a performance vehicle.
Right.
And a performance vehicle means that you want to make a chassis as stiff as possible. The stiffer the chassis, the better your handling is.
There it is.
One of the reasons why we also have a cast aluminum frame,
right?
Because a cast component has very low flexibility, and hence the entire handling, what you feel when you ride at 450,
right,
is a lot of it is attributed to the cast aluminum frame.
Right. It's a little deviation, but below the seat, the cast aluminum frame protrudes a bit.
Yeah.
Was it on purpose so people could put their luggage or?
It was a design element.
Okay.
It is an aesthetic. It is also a structural element.
Right.
But it was also a design element.
Okay.
And it also, as you said, for people to hang something, put helmet. Most people put their helmets around in that area. It has a function as well. Yeah.
Right. So now this brings us to charging. Why Ather chose to engineer its own port versus the Type 6, which is common?
Yeah. So Type 6 only allows for DC charging.
Right.
While what we wanted to build, and this is a lot like back in 2017, and not in 2016, when we started looking at the charging connector, what we realized is that it's and we actually wanted to design for the ecosystem from day one, because we knew that charging connector is always going to be an ecosystem play.
Right.
It is not something which you have to design for one particular vehicle. It is you want to design for the industry and not for the connector. And when we look at the DC or the Type 6 connector, we were not happy that it restricted it to a only DC charging, because some OEM, and we know that there's one OEM which uses a AC charging today. They have an onboard charger and they do AC charging.
Right.
So you want to have the flexibility to do between an AC charging and a DC charging, and that was one very, very big factor which was driving us towards the having our own charging connector.
Right.
Also, sometimes you want to do probably a dual charging. You want to do AC charging and DC charging together. So we thought about a lot of scenarios which you can play around with, and hence realize that having the flexibility of an AC charging and DC charging both in the same connector is very important, and that's when we started. Also, we were not very happy with the cost structure which a Type 6, because Type 6 end of the day was an international design. So the cost structures and all were not very, very, very lucrative.
Okay.
So we went ahead and said, okay, again, we have to design for India.
Correct.
We can't take an international standard because they don't understand Indian ecosystem as well.
Right.
So we went with the target that we have to design a connector which is specifically designed for India and also under the control of Indian OEMs. Because usually if it's under a bigger international umbrella, making a change into that might be a lot more difficult. But if it's under the control of Indian OEMs group, then you can actually have all the freedom to make a change. And in the Indian industry is leading the entire EV transition in two-wheeler.
Right.
So why should we depend on an international player for a charging standard?
Right. Is it open? Type 6 is open or?
Yeah, our charging connector standard has been open for almost about a couple of years now.
Okay.
Recently, it got also accepted as a BIS standard. So we are also working on sort of creating a consortium so to enable other OEMs also to come on board.
Right.
And drive the improvement itself, not just use the connector as Ather has done whatever it could do as a standalone OEM.
Yeah.
But I think when the industry comes together, you have a very high chance of making it even better.
Correct.
And that's what we are aiming for, that creating a consortium and taking it off Ather's plate and giving it to the consortium for the consortium to now grow it and make it a even sophisticated standard than what Ather could standalone make.
Right. Doesn't the Ather also support a higher kilowatt rating?
Yeah, the standard currently supports about 12 kilowatts of power, while we only do about 3 kilowatts of charging currently. And hence it was a forward-looking design. Hence we designed it from the start itself, we designed it for 12 kilowatt because we know that different OEMs would want different flexibility.
Right. One interesting thing I've noticed is budget e-scoot is aimed for the masses.
Yeah.
I won't name it, but they have an inbuilt charger and you only simply plug the wire to your port, as in your wall charger.
Right.
So what are the pros and cons of it? Like it seems to make sense because most people anyways, if they're traveling far, they will carry their charger in their dicky.
Right.
But from like a founder's perspective or some engineer's perspective.
So, I mean, there is no very clear right or wrong in this, honestly.
Yeah.
It's a choice which OEMs make. I'll tell you our rationale for, we actually in our first generation of vehicle, we had an onboard charger. We moved away from that onboard charger in the second generation. Primary reason because first 450 is a performance vehicle.
Right.
So you don't want to load it with extra weight.
Right.
That was one a very important factor in our decision.
Okay.
Second was forget about it.
That is okay.
I think that actually that was a very primary reason. There are other factors which are mostly secondary, but this was a very fundamental reason why we decided to move away from it.
Okay. Since you're on the battery structure, a Cybertruck has this feature where if you enable water wading, it pressurizes the battery just in case. So Ather's by default water wading, how does it look like? How did you test it? So pressurize it?
No, we don't pressurize it internally. It is an IP68 tested battery. So generally, in typical water weight scenarios, it doesn't have any challenge. You can almost up to 15-20 minutes, even if it's submerged underwater, it's not a challenge. Longer than that, yes, it can have a problem. So yes, the pressurization system can be built in, but again, everything comes at a cost, and that's not active.
Is it passively at least pressurized? Like the pack itself is pressurized?
So it's not hermetically sealed pack. Okay. So if you pressurize it over a period of time, it will the pressure will go away anyway. And again, hermetic sealing is very expensive.
Okay.
I mean, like, not very expensive, but it adds to the cost, and you have to, at some point of time, you have to make a choice how much features you want to build in, because you also want to build for the larger mass.
Right. On Twitter, many people are asking what could they charge their friends Ather with their Ather? What are the challenges with that?
No challenge as such, honestly. Technically, it is possible. It will add again some cost, but something which can be looked into. There wasn't actually. We prefer that we have enough charging grid across the city.
Right.
You would rather go and charge there than try to charge it from a friend's vehicle. So technically, it's not a big challenge. But from a practicality perspective, I don't know if it's as important as actually going. You would rather fill up the city with grid and let people go to the grid and charge it. It's much faster to charge it on the grid than doing a vehicle-to-vehicle charging.
Right. So generally in cars, we will talk with this auto hold. Generally in cars, auto hold is through electronic brakes, and if you just whether it's a climb or downhill. Either your scooter doesn't have electronic brakes. So how did you implement auto hold, and how is it so good? Because I'm seeing videos, it just doesn't move. It's like just they're stationary. Not even like there's some correction happening going forward behind. It's just
actually a very, very important point. Right? Like most people do not understand that nuance. That while the feature might be same, the auto hold, the way it is implemented in a car and the way it is implemented on a two-wheeler is very different. Right. And in the two-wheeler, it is or in the 450, it is implemented via motor control. Right. You jam the motor in place to ensure that the vehicle doesn't move forward or reverse. The finesse of it, which you spoke about, and you will see that in not only in auto hold, but every single motor control related feature of ours, like throttle response, magic twist, auto hold as well, the warp plus mode. Every single feature which is related to the motor control, you will see that there's a finesse to the feature, primarily because how good the controls team has spent their time. Controls and actually also the entire hardware engineering as well. Right. It's not just how stiff the auto hold is, but how long it can last. Right. Like you could use auto hold on a 450 for probably 10 minutes, right, and it will not still give away, because again comes the thermal engineering and the hardware design, software design around it. So how good your control loop is, how good your hardware engineering is, how good your software engineering is, all of that put together gives you the final finesse of the feature. And you'll see that across every single feature of Ather. It's 1:1. You might think that, okay, this feature, the other OEM also has it. But then when you get onto the vehicle and test it out, that's when you understand the difference in the finesse of the feature.
That's right. So you said jam the motor. I was under the assumption that you have like a reverse or positive axle.
No, I mean jam the motor electronically. Like not. I mean,
It's not mechanical.
Yeah, it's not mechanical. It's a electromagnetic. Essentially, what you do is you have a motor controller. It has a control loop running in it, right? Now, instead of usually when you give a throttle, you give a power control. Right. That's one loop which is running, which is a power control loop. When you go to auto hold, then you move from power control and then you move to a position control. Okay. Right, and then now you're in a position control loop in it. So it is essentially the same motor controller running a different algorithm to ensure now you don't move from your place. So position control, you jam the position through electromagnetics only, no physical jam. Okay, yeah, because there's no correction happening. It just stops. There's no. Well, it is happening, but again, the control loop is so fast that you will not even realize it. Right? The perturbation, which is, see, every control loop there is a correction, right? Like now it goes down to how strong your PID loop is, right? And that is what gives you the final finesse. Right. Magic Twist, I had a question. You can start Magic Twist from 100% in sulfate. Yes. So where does it dump the additional energy? Right. So so we have 2-3 things happening. One of the easiest to understand is we actually they burn the energy in the motor windings itself. Okay. Right. So you take the energy and then push it back, and you circulate it in the motor windings and actually burn the energy in the motor winding itself. So what that ensures is that for a customer, they don't see a difference in experience when they can use regen and when they can't use regen, and that's very, very critical. Okay. Because if you want to constantly use the reverse motion to stop the vehicle, you don't want to be thinking in your head, okay, now I'm above 90%, 80%, so I can't do this. Right. The people will stop doing it, right? Like, and it's actually a safety hazard. Right. And actually that happened to be on my car. I have an EV, and I left the pedal and it was at 100% charge, and I don't drive it as actually I drive my 450 every day to office, but I don't drive my car, like or even if I drive, my driver is there. Right. So one day I was taking the vehicle, and then I thought it was at 100% charge and lifted my foot off the pedal, and the vehicle just cruising. Right, because the region was not active. The region was not active, and apparently I had a scare of life. And the pedal doesn't always work in. It won't work if you are above 90%. Right, so and that's why. See, basic region is very simple, right? And vehicles have had it forever. Right, a lot of people asked us this question in the past before we introduced Magic Twist, that why Ather vehicles don't have strong regen. The primary factor was this, because we didn't want to give the differential experience to customers. Because we believe it's a safety hazard, right? And for us, safety is very critical. Right. So it's a safety hazard when you have to think in your head, am I above 90% or am below 90%? And that can actually lead to accidents. So hence we said that either accident or people will stop using the feature, and both of it is not desirable. Right. So we said, unless we figure out how do you give the same consistent experience from 100% to 0%, we will not launch the feature. The day we cracked it, we launched the Magic Twist feature. Different hardware was needed for this, or on the throttle, yes, and to some extent on some tweaking was needed on the motor controller as well. Okay, that's why unfortunately we couldn't give it as a update, as a backward compatible. That's right. Certain extra safety features we had to build. Yeah. So the motor will heat up, right, because of this? See, the energy has to go somewhere. Motor will heat up, but again, again, thermal management comes into picture. Right. Motor cools down really fast. Okay. Right. So you'll do this. You'll dump the heat into the motor, and it's only up to like that 100% to 90%. Right. After that, region starts kicking in. So that's not a problem. But the 90% to 100% to that 90%, you heat up the motor, but within few seconds, the heat will get dissipated. So we have actually, and if you've seen the Apex launch videos, we have done a tag test where people just used the magic press, did not use any other in the physical brakes, and they did not see any derating because of that. Or once in a while, if they saw it as well, within few 10 seconds, it was back to normal, and they were able to use the full power.
Right.
And in a regular traffic, there's no duration as such. So and in the traffic scenario, again, you'll see absolutely nothing. You'll never realize that there is the motor got the heat here.
Right.
It all comes down to thermal engineering.
Correct. So since you are on the motors,
right?
What kind of motors? One was popular question, and secondly, why did you have that? I like that sound of Ather, but why is it second wheel and then it transfers instead of?
Yeah. So the first question, it's a PMSM motor. Why we have the second reduction? So the fundamental thing, it started with us saying we don't want to use hub motors, right? Because hub motors add a lot of unsprung mass, and if you are somebody who's studying vehicle dynamic,
I know what is.
Yeah.
Okay.
So unsprung mass is not good, right? Like it makes it doesn't feel like your vehicle doesn't feel planted on the road.
Right.
If you have a high unsprung mass, your vehicle moves randomly.
Right.
So we were day one of design, we were very sure we are not going to put hub motor. So we knew that we have to put a motor on the frame.
Right.
Second, we hate silent vehicles, right?
Okay.
We absolutely hate, because again, we believe it's also a safety hazard. Having a completely silent vehicle. Also, vehicles need to have some sort of a characteristic of its own.
Right.
If you remove sound, is an important characteristic of a vehicle.
Right.
And completely getting rid of it is not something which we are very happy about.
Yeah.
So with that, and the third important factor which came in was the weight distribution. So we wanted, especially with the 450, because it's a performance vehicle, we wanted the weight to be completely centered, right? Like 100% in the center of the vehicle, so that you don't have any lateral weight distribution on the vehicle. This ensures that the vehicle is very solid when you are taking corners, right? And your left turn versus your right turn, there is no difference, right? Like if you have a lateral weight or weight offset, your left turn is different, your right turn is different, and you don't want that. That is not a great feeling on a vehicle. And and we want to ensure that the 450 feels like a very, very strong performance vehicle. So that led us to going with that sort of an architecture. That's how we chose our RPM.
Right.
There is also an important factor into it, that usually high RPM motors eventually turn out to be cheaper than a low RPM motor.
Okay.
So even on a system level. So we're playing around with all these factors. We decided what is the gear ratio which we want, and hence we chose the 2-stage reduction with all these factors sort of playing into it.
What is the origin of the soundbird? Like, what something is rubbing, or what is generating?
Yeah, it's a combination of your transmission, which is your belt, and motor. Both these noise sort of coming together. Okay. That's where the overall characteristic comes in.
It's like a jet engine.
Yeah.
Nice. Yeah, you answered the hub motors part. So you'll have an inverter then for your motor.
Yeah.
So do you have like a very old Ather, like since foundation, to see how it has aged, how characteristics have changed, how batteries, how BMS behavior has changed? How do you do this long-term or decadal testing, suppose?
Long-term?
Say, we were talking about thermal engineering and all of this.
Right.
This will change over years, 5 years, 6 years.
Right.
Do you have like a very old Ather which is 5 years old?
Yeah, I mean, see, the first vehicle which we sold is more than 5-year-old today in the field.
Right.
And then you have a lot of surrogate testing. For example, every single design goes through, like, let's say motor controller, it'll have about 50, 60 odd tests which it goes through. Out of that, 30 will be reliability test, which means that you're testing at different temperature conditions, you're testing at different load conditions.
Right.
You're testing the entire vibration cycle of the vehicle. Then you go through a vibration cycle, then you go through a temperature cycle, and then you dip it in the water, and you see if the seal is staying intact or not.
Right.
And the combination of all these things. So you do like a multi
Aging test.
multi-physics sort of a multi-aging test, right? You add multiple noise factors together and see how it is aging. And these are usually accelerated tests.
Right.
So within like a 2 to 3 days time frame, you can actually you do like salt spray, this, that, all of that, and then you age it to the extent that now you can correlate to a 10 years battery life. We also usually, before any design is launched, about each design goes through about like 40 to 50,000 kilometers on the road individually and across the fleet, because we don't run one vehicle, we run multiple vehicles with the same design.
Right.
So cumulatively, it would have covered about 5 lakh kilometers before it goes on to the field.
Right. Okay. I think we have 3 minutes. I will ask about for your dashboard.
Right.
I don't know what it is now, but earlier it was Snapdragon 212 and 2 GB RAM. Is it still the same? And is this the processor powering the rest of the electronics, or do you have like 2 different computers for your?
Actually, every module has a different processor running. It's primarily to build redundancies, right? Like so, battery has its own microcontroller. Motor controller has its own microcontroller. The Snapdragon thing is a different microcontroller as well. And while microprocessor and Snapdragon is amazing for user experience, but it is not the most. It is not as a microprocessor. Your phone microprocessor can never be as robust as a microcontroller.
Correct.
Right. So all the critical functions are performed by the microcontroller, and they have again multiple redundancy built in there. Right. While the great user experience is what the Snapdragon processor provides.
Right, but so when you push this updates, hill hold update or this stealing update and all of that, so that is handled by what? So it will then get assigned to the right module.
Yeah. So it is a complete orchestration which happens between. So the processor downloads the OTA, and there's a full orchestration which happens between this processor and the multiple microcontrollers, and that's how the OTA sort of takes.
Okay. Last question. So you have Google Maps integration. You probably pay for the API calls to Google.
Right.
So instead of that, why wasn't Android Auto kind of implementation done? Especially now there's a wireless Android Auto and more customized Android Auto, instead of building on top of AOSP and building a whole stack. And
so 2 reasons. One very tactical reason is that Google even today does not have a clear policy for handling 2-wheeler.
Okay.
So the Android Auto for 2-wheeler does not exist. But that is only one part of the story. The other part is we wanted to, and this is what we have seen even with Android Auto, that the experience becomes coupled with the phone model as well. Right? Depending on different phone model, you could have a different experience.
Okay.
And we didn't want the vehicle experience to be impacted by the phone model which you carry. Right? Phone model is your choice, but the vehicle is under our control.
Right.
So we want to ensure that across the fleet, the experience is consistent, and we would rather build that experience which we can 100% control. Because when something doesn't work, you don't think whether it is a phone or it is Android OS or it is Android Auto or it is vehicle. You're just frustrated, right? You don't want that. And that's why to have a very strong control on the experience of customers, we wanted to control the entire stack, from hardware to the OS to the entire application layer as well. So we don't have any dependence on whatever phone you use.
But if it was not like your and I have food, but you find the better and to do off. It's a very trust that. It's a very different part. It's very I trust. It's a factor. It's such I've got one. It's bad. It's bad. The thing is, the way the faster was the bad. And the no. I'm going to talk and the tasty. I will let the biggest tasty. And the deputy will do first after the trumping that opened again. After the end of the man, that's one third something, but I get it up by your engine and I can't and for the better. Don't come to it. It's not the age for back office. I like it with